Welcome back on the exciting video. Today we are on lesson 8 of programming with C++, and this slide is a reference of Dr. Freeman and Wanda Kweku's slides. So on today's lesson we are going to talk about namespacing and exceptions, and the objective for today is to learn how namespaces in C++, understand compilation and program structure, understand using header files, learn about exceptions. So namespacing is a feature that provides a way to group related identifiers such as variables, functions, and classes under a single name, and it provides the space where we can define or declare identifiers, that is variable, methods, class, and in essence a namespace defines a scope. So begin with a keyword namespace followed by the namespace name. So this is how the structure of a namespace is. You begin with a namespace and the name, and the namespace name, which we can use namespace program. Then you bring your curly brace, and inside it you write your subject, you write what you want to write inside the curly brace, then you close it. So namespace definition: define a namespace called programming. So this is how we are using it: namespace programming. Then inside the curly brace we create out a void function. Then inside the void we need to see out programming namespacing. So it is, and this is what namespacing definition. We are defining the namespacing programming. Accessing namespacing members: access the members of namespacing using scope resolution operator. That's a double colon structure. So the structure is namespace underscore name double colon member underscore name. So this is a practical example of namespacing. So with this, you write namespacing, then you bring in the namespacing name, which is programming. Then inside it you create a void function. So void function. Then inside the void function, you will see out inside programming namespacing. Instead of we using only cout, we use std std colon cout, because we are not having using namespace std outside the int main, which we usually have it because it takes care of the you see out something or you outputting something. So with this one we don't have our using namespace std, so we are creating our own namespace. So use std colon cout inside program namespace. Then you come and close you end the line. So end std colon end line. Accessing namespacing members: so after writing your code outside the int main, you want to access that namespacing. So you come inside the int main, then you call that namespace, which is the programming, then colon then you bring your function, which the function is for the void, so it will see out inside program namespace. So namespacing with using directive. This directive tells the compiler that the subsequent code is making use of name in the specified namespace. Namespace with using directives. So hashtag include IOStream. You are creating your own namespace. So namespace programming. Then inside you have void function, then you see out inside first space, then you end line. And this is using with you namespacing with using directives. So using your directives, you using namespace programming, you have created your own namespace. So you come inside the int main then you call the function. So with this one, using directives, write or call the function as you did for accessing the member space. With this one, you use using namespace programming. You bring the using namespace programming after closing the curly brace for the namespacing program. So using namespace programming, then you call the function inside the int main for it to see to see out first inside first space. After this, I'll do a practical example for you to see after the slides. So namespacing with directives, this is how it is. Yes. And there are types of namespacing. You have the inbuilt namespace, inline namespace, anonymous namespace, and global namespace. So we start with the inbuilt namespace. The inbuilt namespace is a namespace that are part of the C++ library, which contains most of the built-in functions, objects, and classes. So with the inbuilt namespace, they are part of the C++ library. For example, we have let's say cout. They are part of the C++ library. Also, it also avoids conflict between user defined and library defined functions or variables. So the inbuilt std namespace, the std namespace is a namespace that is part of the standard library. It is part of the standard library which contain most of the standard functions, objects, and classes like the scene, cout, vectors, as I mentioned earlier, etc. And it also avoids conflict between user defined and library defined functions or variables. So inbuilt namespacing, we have using namespace std. It's an inbuilt namespace whereby it is part of the standard, or it is part of the C++ library. So you are writing a code. You declare a variable, then initialize a number to it. So you do int a is equal to 3, b is equal to 7, then you terminate it. So you comment on that, which whereby cout and endline are part of the std namespace. With this, they are part of the std namespace. So the cout are part of the std namespace. They are part of the standard library of the program, of the programming language. So you move to the inline namespace, where inline namespace is a namespace where its members are accessible directly without using the namespace name. So it is accessible without accessing it directly without accessing it directly. Yes. And this is inline spacing. This is a practical look of it. So inline namespace, inline underscore space. You bring void display whereby the display, you should display what inside inline namespace. So this is how the inline spacing is. The syntax for it: inline namespace, inline underscore space. Then what you call it inside the int main for it to display what you are seeing out. You move to anonymous namespace, and anonymous namespace is a namespace. It's a namespace that does not have a name called an anonymous namespace. It ensures what that its entity. It ensures that the entity in the unnamed namespace are limited to that file. The entity, it ensures that what the entity in the unnamed namespace are limited to that file. It is limited to only that file. So this is how it is. The code for it: anonymous namespace. We will bring what namespace inside it. You initialize what value, the equal 10. Then after that, with this one, it doesn't have any anonymous. Let's say it will start with anonymous namespace is equal to anonymous underscore space. With anonymous, it doesn't have that. It starts with namespace. Then you bring your curly brace. Inside it, you declare what a value, or you declare variable. Let's say int value is equal to 10. Then with this one, you want to see out the value over there. So you see out value is equal to 10. See out value is equal to what? 10. So it will see out the value. So you move to what? Exceptional handling. Exceptional handling is based on keeping the normal functionalities of the program separate from error handling. The basic idea is that error occurring in one particular part of the program are reported to another part of the program, known as calling environment, and the calling environment performs central error handling. The part of the program that performs central error handling in the calling environment is referred to as an exceptional handler. Components of exceptional handling. There are two parts of implementing exceptional handling, whereby the first component is the part of the program that can throw exceptions, and the exception handler that will process the various exceptions types. So these are the component of exception handling. Try and catch blocks. C++ provides an inbuilt feature for handling exceptions using try and catch blocks. It is an exceptional handling mechanism where the codes that may cause an exception is placed inside the try block, and the code that handles the exception is placed inside the catch block. So try and catch block syntax. There's a syntax for try and catch blocks. You bring your try, then bring your curly brace code that might throw an exception, and this is how the catch. Then you bring your parentheses, exceptional types. Then you bring your curly brace. Then you write your subject or your code. Then you move to throwing exceptions. Throwing exceptions means returning some kinds of value that represents the exception for the trying block, and the matching catch block is found using the type of the throw value, and the throw key is used to throw the exceptions. And this is how the syntax is, as you saw. But this for true exceptions. And there are three types of values of true exceptions, whereby we have the built-in types, standard exceptions, custom exceptions. So you start with what? The built-in types, whereby this art is after writing or declaring your variable x is equal to 7, you will start with try, then you bring your curly brace. If x modulo 2 is not equal to 0, it's what? True what? True -1. Then you terminate. And you bring what? You continue with the cache int e. Then you bring your curly brace, see out exceptional catch. Throwing standard exceptions. Standard exceptions are the set of classes that represent different types of common exceptions. And all these classes are defined inside what? The std, except header file, and mainly derived from the std exceptions class, which acts as the base class for built-in exceptions. And this is the hierarchy for C++ exceptions. So the exception for the central part, whereby we have what? Our logic errors, and which under the logic errors we have what? Individual arguments, domain errors, length errors, out of range. And we move to the runtime error, the range error, the overflow error, and underflow error. And we have bad function call. We also have bad alloc, which is bad alloc. And we also have bad cast. So we move to what? The standard exception. So throwing standard exception, the second type of what? Throwing exception. Whereby with this, you bring what? Hashtag include IOStream. Hashtag include we are working with what? Another standard library. Yes, another inbuilt or a C++ what? Library, whereby we use vectors. Then vector, then you bring what? Your less than and greater than, and inside you what? Int. Vector, which is v, is equal to what? 1, 2, 3. So you bring what? Try, then bring your curly brace, access out of bound element v.at equals, into parentheses, 10, then you terminate. Then catch out range, catch out, whereby you use what? Out of range, e. Then see out what? Catch, when e dot what? And benefits of exceptional handling. Separation of errors handling code from normal codes. This is the first benefit for exceptional handling. Separation of error handling code for normal codes. Functions or method can handle only the exceptional chosen. And grouping of error types. This is what the benefit of exceptional handling. Separate compilation. A function is what? Is defined as a function declaration in which the body of the functions is presented. Structure. A structure is what? A structure is a function definition. Includes a return type, a name, a parameter list, which is optional, and a body enclosed in curly brace. That's a structure. So with this, we did it at what, lesson 2 there, where the structure is what, defined. The function is defined inside what, curly brace. So we have what, our return type, a name, a parameter list, which is optional, and a body closed and a body enclosed in what, a curly brace. And with this one, we know it already. Yes, this is in lesson 1 of programming with C++. And C++ header files. C++ offer its user a variety of functions, one of which is including a header file. In C++, all the header file may or may not end with the .h. Header file in C++ are basically used to declare an interface of a module or any library. And components of header files, whereby we have what, function definition, data type definition, and macros. And there's a syntax for header files. Hashtag include file name.h. You are creating what, your own header file, whereby we have a header file which is what, iostream. Hashtag include iostream. So you have hashtag include header file. You are creating your own header file. Or you can do it like this: head file name.h and header file importing them into the program with the help of what, a preprocessor directive, whereby the hashtag is what, a preprocessor. So you help what, import them. You help import the program what, by using what, a preprocessor directive. This preprocessor directive are used to instruct the compiler that this file needs to be what, processed before compilation. And there are types of header files, which we have what, a standard header file, which is also known as what, a pre-existing header file, and we also have user-defined header files. And the standard header files or pre-existing header files, these are files that are already available in the C++ compiler. We just need to what, import them. And standard header files are part of the C++ standard library and provides commonly used functionalities. They contain the declaration of standard function, constant, and what, classes. And standard header file or example, this is an example of it, whereby we have what, iostream. We have what, a header file, iostream. We have the cmat, the string, the seno, the vector. They are all what, they are all standard what, header files or pre-existing. So what you need is what, to import them in writing your code. And user-defined header files. These files are defined by the user and can be imported using hashtag include. These are mainly used to encapsulate your own functions, classes, or declarations, so that they can organize our code and reuse our code by separating it in different files. Write user-defined header. Write your own C++ code and save it .h extension. There's a syntax: int sum of two number. So what, int a, int b, return a plus b. So this our own what, header file, whereby we are using header file of sum. You are adding what, two numbers or multiple numbers. So this is about what, sum. So this is a header file, hashtag include sum.h. int a is equal to 13, b is equal to C out what? Sum is what? Sum of two numbers, a plus b, a comma b, end line. So we know what? It will return what? A plus b, whereby 13 plus 22. Creating a header file. A header file should not what? Contain 1. Ordinary function definition, data definition, example int a. Aggregate definition, example short tbl, then you bring what? Just 2 square brackets, whereby the 2 square bracket contains what? Let's say an array 1 2 3, and what? Unnamed namespace, example namespace, then whereby you comment yes, and using what? Directives, example using namespace FOOO. And programs. A program is what? It's a collection of separating complied units combined by a linker. A linker before what? A compiler, as we did in lesson 1. Every function, object types, except object type, etc., used in this collection must have a unique definition. A program must contain exactly one function called the main. Yes. And program components. The main computation performed by the program starts with the invocation of the global function, the main, and end with a return from the main. The return types of main is int. Syntax int main. And what? Programs. We move to programs. What? Termination. A program can terminate in several ways: by returning from main, by calling exist, by calling about, by throwing an uncalled exception, by violating non-exist, by calling quick exist.